Today we'll be talking about 45, 45, and 90 right triangles. Please grab a pencil and make sure you take the notes. Let's start by looking at a square. What I need you to do is first draw a diagonal from one corner to another. When you do this, the angles are bisected so that you have two 45, 45, 90 triangles. Here's one of them, and here's the other. Next, I need you to label each leg X. Each leg is the same measure because we have a triangle. We have a square. All squares have the same side lengths. Next, I need you to find the hypotenuse of that 45, 45 right triangle. We can do this by using Pythagorean theorem. X squared plus x squared, because that's each side, is equal to the hypotenuse squared. So, how many x's do you have? You have 2. So you have 2x squared is equal to the hypotenuse squared. We had to take the square root of each side to get rid of this squared right here. When you do that onto the side that's 2x squared, the squared with the x and the square root would cancel, so the x came outside of the radical. You are left with the square root of 2, which is what we have right here. So x square root of 2 is what the hypotenuse equals. So anytime that you're solving for a missing length in a 45, 45, 90 right triangle, you can label it like this, and you need to label it like this every time. Each leg is x. The hypotenuse is always x square root of 2. There's a ratio of side lengths that always exists when you're talking about 45, 45, 90 right triangles. They're x, x, and x square root of 2. That is why you need to label it, because in some way or fashion, if you know one leg, you can find the other. Or if you know the hypotenuse, you can find the other legs, the other sides of the triangle. So make sure you label it just like this every time we're working on a problem. Now, let's look at those examples. Find the lengths of the missing sides. Remember, I just told you that we need to write our x, x, and x square root of 2 values on each triangle that we work with. So side AB, which is a leg, is equal to x. Side BC, which is also a leg, is equal to x. And our hypotenuse, AC, is equal to x square root of 5. Square root of 2. If you'll notice, we have that this side length is equal to x, but we also know that it's equal to 5 because that's the information that's given to us. So if BC equals x and BC equals 5, we know that our x value is 5. So if x equals 5 and the side length AB is equal to x, it also equals 5. So AB is equal to 5. So what do I know? I know x equals 5. Where else do we see an x on this triangle? Right here. What you need to do is you need to plug in your x value into the x square root of 2 side length. Please make sure you get this down. So if I know x equals 5, and I know that the side AC is equal to x square root of 2, I plug in the 5 for the x. So you kind of overwrite what that x is. So my side length for AC is 5 square root of 2. Our next problem says to find the lengths of the missing side. We're given a triangle that has the value of the hypotenuse. So we're given the hypotenuse. Let's start by labeling each side. Side AB is representative of x. Side BC is representative of x. And side AC is equal to x square root of 2. We have a whole number that equals x square root of 2. So what do we need to do with that? There are 2 steps that you need to write down. Step 1 is you divide that number by 2. Step 2 is you multiply by the square root of 2. It's easy. Watch. 4 divided by 2 is equal to 2. My next step says to multiply by the square root of 2. Well, you know you can't multiply those numbers together. So my answer, x, is 2 square root of 2. That's how you find x if you're given the hypotenuse. We'll do it again. Divide your value that you're given for your hypotenuse, which is 4 in this case, by 2. 4 divided by 2 equals 2. Then we multiply by the square root of 2. Since you can't multiply those together, your x value is just 2 square root of 2. So AB equals 2 square root of 2, because that's this line right here, and BC is also equal to 2 square root of 2. And you're finished. Remember from yesterday that this is a completely acceptable answer. It is the most correct answer that we can give without having to round. Let's look at a couple more examples. Find the lengths of the missing sides. AB, BC are legs, and AC is your hypotenuse. So again, you're given your hypotenuse. Let's label each side first. X, x, x square root of 2. Remember what I said our rule was. When you're given the hypotenuse, to find the value of just x, we divide by 2, and then we multiply by the square root of 2. So what we need to do is divide by 2 first. 3 times the square root of 15 divide by 2. We can't simplify that anymore. So now we must multiply by the square root of 2. 3 can't multiply by the square root of 2, but the square root of 15 and the square root of 2 can be multiplied together. 15 times 2 is equal to 30. So we have 3 square root of 30 divided by 2. The square root of 30 doesn't simplify down, so that's our value of x. It's pretty funky looking, but that's our answer. X is equal to 3 square root of 30 divided by 2. BC is equal to x as well, so it's your same answer. 3 square root of 30 divided by 2. And our last problem. Find the lengths of the missing sides. Go ahead and write in your x and x squared root of 2 values. X, x, x square root of 2. Well, this is interesting. We have a value, but it doesn't look like a whole number. It's not, but still, this x, the 2 square root of 3, is the whole x value. So if AB is x and it's also 2 square root of 3, BC would be the same thing, 2 square root of 3. So now what do? Well, we take our x value, which is 2 square root of 3, and we plug it in for x. So I'm looking at the x squared root of 2. What's my x value? It's 2 square root of 3 times the square root of 2. Remember, you can't multiply the 2, but we can multiply the square root of 3 and the square root of 2 together. 3 times 2 is 6, so our answer would be 2 square root of 6. That's the hypotenuse for this triangle, 2 square root of 6. Now I just want you to take a break and watch what I do to solve these triangles. I'm going to give you a few more examples. Say we have a triangle ABC such that the side BC is equal to 7. And it's a 45, 45, 90 right triangle. What we'll do is we'll label each side x, x, x square root of 2. I know that my x value is 7. So I know side AC is 7 because I just plugged 7 in for x. And I know AB is 7 square root of 2. Again, because I'm plugging in my x value of 7 into wherever there's an x on my triangle. Really what this is finding the pattern and filling it in. There are a few hairy steps when we're given a little funny looking hypotenuse or a funny looking side length, but you can do the math. Let's try another one. We're given a triangle ABC such that AB is equal to 10. Oh, look, we have a hypotenuse. Remember our steps. Divide by 2, multiply by the square root of 2. So if we did this, then what does this help us find what our x value is? If we did this, 10 divided by 2 is equal to 5, and then we multiply by the square root of 2. 5 square root of 2. 5 square root of 2. I forgot to label each side. This is x, and this is x square root of 2. But you get the picture. Now let's look at this example. We have a triangle ABC such that BC is equal to 3 square root of 5. If you go in and label each side x, x, x square root of 2, we can solve and find out what the value is. Remember, 3 square root of 5 is the whole x value. So if BC is 3 square root of 5, AC is also 3 square root of 5. That's our x value. So if x square root of 2, I need to plug in my x value, which is 3 square root of 5 times the square root of 2. 3 cannot be multiplied, but the square root of 5 and square root of 2 can. Square root of 5 times the square root of 2 is the square root of 10. So our answer here is 3 square root of 10. It's important to remember the steps. First, label your triangles. Label each triangle that you get. Secondly, if you're given the hypotenuse, don't forget to divide by 2 and then multiply by the square root of 2. I know each of you can do this. Please remember, if you have any questions, you can email me. I'll be at school tomorrow for tutoring in the morning. If you have any questions, please don't hesitate to come in.